All right, so here is the concept for limiting and excess reactants. How much water could be formed if you have 5 grams of oxygen and 5 grams of hydrogen? Guys, it is super, super common for people to say 5 plus 5 means 10 grams of water can be formed. And you couldn't be more wrong doing that. We're not testing this here, but if we were to test, when people give me that answer, 5 grams of hydrogen, 5 grams of oxygen equals 10 grams of water. Guys, like just that one problem, they do so poorly on that one problem. Like probably the best you could do on a test is now 75%. You just missed a quarter of the test because you didn't understand this concept. So do not just add these together. Don't do it. It's a common mistake. It's way too easy to do, but don't do it. You have to do stoichiometry. There's more to this problem. Congratulations. You know the law of conservation of mass. You can't create, you can't destroy mass. So congratulations, you're adding 5 grams and 5 grams, but that doesn't mean you can make 10 grams of water. It's not at all what it means. Here's what we have to do. We have to do stoichiometry, and that always starts with a balanced chemical equation. Hydrogen plus oxygen makes water. All right, we all know the chemical formula for water, so we're not too concerned with the subscripts there. We know that those are right. How about these two? Is either one of them a diatomic? Yeah, they both are. They're both diatomics. Put the 2 there, put the 2 there. Now it's time to balance. So now that we've got our subscripts, we're done with subscripts. Time to balance with coefficients. So 2 hydrogens, 2 hydrogens. We're off to a good start. Awesome. 2 oxygen, 1 oxygen. Guys, I can't put a little subscript 2 here just because I want 2 oxygen. If I did that, I'd be changing what I have. I don't have hydrogen peroxide anymore. So instead, the way to do it is put a coefficient 2 out front. I still have water. I don't have H2O2. I still have H2O, but I have 2 of them. That gives me my 2 oxygens. But it also changes my number of hydrogens. Yeah, now I've got 4 hydrogens over here. So I've got to change this side. I need 4 hydrogens over here. But that's a pretty easy fix. There we go. Now we have a balanced chemical equation. All right, because we're good chemists, we're going to put in our states of matter. You're probably familiar at this point that hydrogen's a gas. Oxygen's a gas. Water is a liquid. Cool. All right, there's the first part. There's the first part. Now we need to solve for our problem with stoichiometry. So we start these off with question marks. What are we looking for? How much water? How much water is equal to? Hey, we're going to have to do 2 stoichiometry problems for this. We can't do it just one. You get to pick which one, though. Which one do you want to start with? We start with hydrogen or we can start with oxygen? Which one do you want? Hydrogen? Sounds good. There's hydrogen. Okay, first stoichiometry problem. 5 grams of hydrogen. So we need to go from grams of hydrogen to moles of hydrogen. Here's hydrogen off the periodic table. So again, I'm going to skip down a couple of lines. I know I'm going to need this area here. So here's my number off the periodic table. Multiply it by 2 because I need H2. Gonna get my calculator out here too. I'm gonna use parentheses. I'm just gonna type it in like I see it. I can use that value now up here, grams to moles. Next up top. Now we're going to use our balanced chemical equation to go from moles of hydrogen to moles of, we're looking for water. So moles of hydrogen to moles of water. We look at our balanced chemical equation. It is a 2-to-2 ratio. So 2 moles of hydrogen makes 2 moles of water. All right, final step, and I got to come down here and write too large to keep going. I need to go from moles of water to grams of water. And again, I'm going to need to do a molar mass conversion for that. Don't know the mass of water off the top of my head. So 2 hydrogens, hey, that's going to be the same thing as I had up here. Plus 1 oxygen, H2O, or 1 oxygen, 15.9994. So we add those two together. And let the calculator do all the work here. And there's our mass of water. Molar mass of water. And I know it's probably not going to matter. Not going to matter. But we need to get good with sig figs anyway, so might as well practice them. Hydrogen goes 5 places past the decimal. Oxygen only goes 4. So my answer should only go 4 places past the decimal. That's out to the 2. I'm going to underline the 8. It's not significant. I don't want to get rid of it yet, but I'm going to underline the 8. Cool. And there's my mass of water, grams to moles. Which one do I want on the bottom? Well, again, I look back up here. I've got moles of water on top, so I want moles of water on the bottom. And that's a moles to grams. The grams up top. Don't like that slash. Don't want that slash. It's impossible to work with, to tell you the truth. This flat line right here is the same thing as a slash. 18.01528 grams per mole. Grams per mole. Cool, next part. You don't have to do this. I think it's kind of fun. But I like to make sure that my units get crossed off here, gets canceled out. Grams hydrogen, moles hydrogen, moles hydrogen, moles water, moles water. Those units all get crossed off. We're left with only grams of water. That's exactly what we're looking for, so we're in good shape. And we'll bust out a calculator here. 5.0, we divide by numbers on the bottom, so divided by 2.01588 times 2, we multiply by numbers on top and divide by numbers on bottom, divided by 2 times 18.01528. Should be an underlined 8 right there. It's not significant. Press the equal button. There's our number. Again, let's go back and check our significant digits. This number only has 2 total. More than 2, infinite, more than 2. Our answer should only have 2 total digits in it. So the 4 and the 4, there's my 2 total. The 6 after the 4 is enough to round up. So I'm going to call this 45 grams of water. No box around it yet. That may not be my final answer. It might be, but it may not be also. So no box around it yet. Hey guys, quick heads up. I've texted you guys, some of you guys. I need to see your face in the camera, or I can't count you as present. So if you don't get your faces in the cameras, camera on, face in it, I'm going to mark you as absent. All right, so there we go. 45 grams of water, but we're not done yet. That's how much water we could make with 5 grams of hydrogen. But we've got another issue here. We've also got 5 grams of oxygen. So we've got a second problem we got to set up. It's going to look very much the same as the first one, and we're going to be able to use a lot of the problems from the first one. So we're still looking for what mass of water? And this time, though, we're not using hydrogen, we're using oxygen. So figured out how much water I can make with 5 grams of hydrogen. Now I have to do the same thing with my 5 grams of oxygen. In another Stoic problem, we know that grams of oxygen is going to go on the bottom. How do we know that? Well, because it has to cancel out. So we need to figure out the molar mass of oxygen. We'll use our periodic table for that. There's oxygen. We have to multiply it by 2, though, because there's 2 of them. There's our molar mass of oxygen. Cool, that's grams per mole. I can put that in over here. Moles per gram, grams per mole, all the same. The rest of this, then, we already have it all set up. So next, now that I've got moles of oxygen, I can use my balanced equation, excuse me, go from oxygen to water. 1 oxygen makes 2 waters. I want the oxygen on the bottom. Two waters on top. Final step then, got to get to a mass of water. And hey, why do that all over again? I've got it right here. We just pull it down from up here. So there we go. We're all set up. Let's double check. Again, it's kind of fun to cross them off anyway. So grams of oxygen canceled out. Moles of oxygen canceled out. Moles of water canceled out. We're left with grams of water. That's exactly what we're looking for. Sweet. 5.0 divided by, it's on the bottom there, 31.9988. Times 2, it's on the top, times 18.01528 on the top. Compute button, just 2 significant digits, way more than 2. Infinity, way more than 2. So we're going to be limited to just 2 significant digits, the 5 and the 6. The 2 afterwards is not enough to round up. Let's call that 5.6 grams of H2O. All right, so how much water can we actually make? What's that? Okay, another common mistake. This one will at least get you most of the points. Most of the points. Most of you guys probably didn't hear that. Somebody was saying 50.6 grams. They added these two together. If you add these two values together, you don't have the right answer. You don't have the right answer. But at least you're going to get most of your points. Remember I told you guys at the beginning, if you add these two numbers together, you're going to miss like 25% of the test. All of this problem and 25% of the entire test. At least if you add these two numbers together, at least you guys did most of the work. And so I can give you most of the points for this problem. But no, the final answer is not going to be 50.6. Let me give you a real life example. Maybe you guys find this more relatable. One hot dog plus one bun yields one hot dog in bun. Here's the issue, though. I don't know if you guys have ever done this. You guys are young. You probably don't go grocery shopping very often. But maybe you guys have noticed when you go to the grocery store, you go shopping at the grocery store, they sell hot dogs in packs of 10. So when you buy hot dogs in a pack of 10. 10 hot dogs at a time. You guys ever noticed that? You get like 5 links on the bottom and then 5 links on top. You know what I'm talking about? You've seen a pack of hot dogs before. So you buy hot dogs in a pack of 10. Buns, on the other hand, you buy in a pack of 8. I don't know why. I don't know why they can't get together and say, hey, we're selling 8 at a time. Maybe you should sell 8 at a time. Or vice versa. Hey, we're selling 10 at a time. You should sell 10. But they don't. They don't get together. It's super annoying. It's awful. But you can buy hot dogs in packs of 10. And you can buy buns in packs of 8. It's super, super annoying. If I go to the store and I buy 1 pack of hot dogs and 1 pack of buns, how many hot dogs in a bun can I make? No one's going to tell me 18, right? Why would you? No, I can't make 18. I can't make 18. Everybody knows that. You guys can see that. So it's kind of the same thing. And the reason why I'm saying this is because I've taught for years and years and years. I know some of you will try to say, you can make 10. No, you're doing the same thing. You're adding your hot dogs and your buns. You can't make 18 buns. How many hot dogs in a bun can we make? With 10 hot dogs and 8 buns. Yusuf? 8. Yeah, we can make 8 hot dogs in a bun. We can make 8 hot dogs in a bun. I can't make 18. Don't add them together. You guys wouldn't do that in real life. Why would you do it in chemistry class? Don't add them together. In this particular example right here, buns are what we call the limiting reactant. Buns are what we call the limiting reactant in this problem. That's because they limit how much we can make. When we try to make our 9th hot dog in a bun, we can't do it. We're out of buns. They limit how much we can make. Hot dogs, on the other hand, are what we call the excess reactant. Excess is like extra. So we have extra hot dogs. We've got more than enough. In fact, I mean, you guys, we used to ask this. I don't think this year I'm going to. We've got, this year's just too bad of a year. But I could ask, how many extra hot dogs would you have? And you guys can all do the mental math. And say, well, you're going to have a remainder of 2 hot dogs after you make your 8 hot dogs in a bun. Again, we used to do that for our chemistry problems. I'd say, how much extra reactant will you have? I don't think we're going to do it this year because this year stinks, but we could do that. You guys could figure that out if you had to. You can do it in your head right now. Let's go back to this problem. Well, you guys have your own notes. You guys can see it on your own page. How much water can we make? Yep. If you guys at home didn't hear, we can make 5.6 grams of water. Circle it, put a square around it, whatever you do. 5.6 grams of water, absolutely. As soon as I try to make 5.7 grams, guess what? I'll be out of oxygen. We run out of oxygen at 5.6 grams. We don't have enough. We can't go on. I've got plenty of hydrogen. I could make 45 grams of water with my hydrogen, but I don't have that much oxygen. I'm going to run out of oxygen at 5.6 grams. So in this particular example, man, oxygen is the limiting reactant. Hydrogen is the excess reactant. We've got more than enough hydrogen. How is that the case? We started with 5 grams of each. Well, you guys at home still see my document? Kind of lost connection here in the classroom. All right, so we started with 5 grams of each, 5 grams hydrogen, 5 grams of oxygen. Well, look at their molar masses. 5 grams of hydrogen is a lot more hydrogen than 5 grams of oxygen. It's kind of like the old question, what weighs more, a pound of bricks or a pound of feathers? They weigh the same. But what are you going to have a lot more of if you're counting total numbers? Yeah, you're going to have a heck of a lot more feathers if you have a pound of each. Same thing, 5 grams of hydrogen is going to give you a lot more hydrogen than 5 grams of oxygen. Questions?